Okay, sige. I will just have to do recording. Mag face to face na kayo by next ano? Sali kayo sa face to face.
Siguro.
Okay. Depende sabot. Depende sabot. All right. So good afternoon once again. So for today, we're going to focus on the tree structures. So by the way, our module 2 is about the hierarchical and non-linear data structures. No, so it's actually part of the data structures. Only that the things that we discuss here in discrete structures are only for concepts. No, purely concepts lang. Unlike when we in the course of data structure, since that is a P, no, it means it's a paired, it's a laboratory data structures and algorithms. The things that we discuss here, like trees and any related topics about trees, will be discussed there in the data structures and algorithm, as well as the implementation, in whether you implement it in C++, in C, in C sharp, in Java, or in Python. So, and that is, I guess, if you are able to pass this course, that means you can take data structures and algorithm. Okay, so again, this is just pure concepts. All right, so let's get back to general trees. I-review muna natin, no? So just a recap of the general trees. So these are the different things now, why there is a motivation on the discussion of trees. So by the way, if you try to look at your, it's a Windows Explorer actually in what they call this one, Windows Explorer in Windows, and in here now in ano is the Finder. You can see here tree structures. So actually this one is a tree structure. So this is the what they call this one, the application of trees now. So and most probably this is general trees. So we have under our favorites node, it has different children. So we have 1, 2, 3, 4, 5 children. So also, as you can notice, every time you click on a certain drive or a certain file, like here or here or anything, you can at the parang right left side of your Windows Explorer, or in here in your Finder, you will notice here that this one is the root node and all these are the children. So there, no, up to tapos under this are also mga directories niya. So ayan, so this is one of the applications of trees. So the idea of really trees in computer science is that it is the searching mechanism, no? So compared to linear data structures kasi, or linear structures, mathematically you'll have to visit from one data all throughout the rest of the data, no, from the beginning up to the end in a linear manner. So that's why it's called linear data structures, and we'll be discussing that. Actually, you have been discussing that so far in your programming one, and there's much more in data structures and algorithm. So particularly mga stack queues, linked list algorithms, arrays, array list, and vector. So these programming concepts are all linear data structures. Now, in the field of tree data structures, again, it's nonlinear. You can just navigate to any children of this particular directory. So this is the let's say this is the root node, and under that node you have the nodes here. So these are mga other directories, no, or other directories of in your computer or machine. Okay, so far this MacBook Pro has 4 children, and each of the child, or each of the child of MacBook Pro directory has also children on its own. So that's actually the idea of trees. Okay, so going back to general trees, ayan, so these are also um, I mean, the linear data structures are used into, so as I've mentioned, like list, linear list, stack queues, array list, and even like vector or linked list. These are used uh, by our most of our operating systems now, particularly in the scheduler. So scheduling of jobs, and we'll be discussing this further in data structures and algorithm. So in terms of the drawbacks of list, of course, it is not fast, it is not efficient, and as we all know, efficiency is becoming a standard. Whether in a transaction, whether you are in a banking transactions, whether you're in a point of sales. No, let's say you're going to go to the market uh, and make some parang orders, no, or like anything that can be performed sa transactions sa point of sales, mas okay siya pag mas mapadali na to ang transactions. Whether there are actually it's external factors that affects the turnaround time in that particular transaction. Pwede na uh, isa lang ang imuhang POS, or pwede na daghan kag POS but you have really a lot of customers. So it may affect the external these are the external factors that affects the process sa imong transactions. But of course, we as computer science, now we position ourselves into how much we can actually optimize, how up to what extent we can actually maximize the capability of our transactions in making it na mas faster siya, even if there are parang walang bottleneck ba, even if there are a lot of customers coming in, you can still cater this customers. Okay, so that's actually the idea of this what they call this one, tree structures, no? So because of the advantage of the linear data structure, so there, no, trees are basically the extension of linked list. Though you have I don't know if you have if you have already an idea of linked list. These are linked lists are actually a data structures that are dynamic arrays, so where it has node, and basically trees are actually composed of nodes. And when we talk about nodes, it composed of the data as well as the address now, and the address is pointing to the next node of that particular value. And yeah, if you're a little bit confused of that, we're going to discuss that in the data structures and algorithm. So with the, of course, implementation of a program. So because again, trees are the extension, or the parang it's the improved uh, structure of a linear list. Okay? So ayan, no, I've already shown to you example of a tree is katong mga sa Java. When you have your VS Code there, you have the project as the root node, and under it are its children. So it forms hierarchy, no? So yeah. So fast, so as I've told you, fast searchable collections, because you don't need to visit from one what they call this one, from one location to the next location in a contiguous manner, like pasunod-sunod, no, sequential. So we don't do that, because in a tree you have the option to choose either the right node or the left node, and under the that particular node there is also another left and right nodes. Okay, so yun, no, that's the motivation, or that's actually the why tree is really important as a computer science. Okay, in fact, um, some machine learning and machine learning methods and machine learning mga capabilities has applications of tree structures. Example of which that I know is decision tree. No? For a robot to create decisions by predicting the whatever decisions that we are going to uh, invoke to the machine, something like that. Okay, so you're gonna be knowing that when you reach your in the particular sa ano na machine learning someday, no? So yan, so a tree is composed of the nodes. It is represented by a T, or it is denoted by a T. Okay, and then as you can see here, you have the nodes here, particularly A, B, C, D, G, H, I, and so on and so forth. So each of the node has connecting edge. So what, by the way, we call this as an edge, the connection between each and every node in our tree. So as you can notice, this is an example of general tree because, or a tree, because it has the a connection, direct connection to its parent, as well as, of course, its children. So whenever there is a node, and that particular node is actually related to any other node, even if it's not indirectly connected to that particular node, that this would mean it's a graph. Now, it's also another mathematical theory which is called graph structures. So actually C++ applied that graph structures in kasi kung if you are familiar with C++, there is this what we called inheritance now na concepts in the one of the principles of object-oriented programming. So also these things are applied or implemented there. So ang C++ supports multi-level inheritance as well as multiple inheritance. So multi-level meaning there is a hierarchy of interrelationships within the classes. So with Java, it does not support multiple inheritance, but it supports multi-level inheritance. So it follows that Java supports only this kind of uh, inheritance, no? Only one, it can only has parang one parent. Unlike here, pwede siya daghang parents and the node can be connected to any other children of even if lahi ang parent. So this is of course non-tree. So usually or most probably this could be a graph, this graph structures. But there are conditions that we set na we could say that it is a graph theory. So let's go back to the terminology. So root, that is the topmost node of the tree. Usually, pag may untag node, it refers automatically the root node. So, but again, may to just to avoid confusions no of the terms, when we say node, all of your tree, okay, is I mean in your tree, it is all composed of nodes. So everything that we see there in our tree are all nodes. And then a node contains the data as well as the address. Kanang address, it points to the next node. So of course, dili pa nato na siya maano because we never touch something as like gi-implement nato siya in a program. So with this, root is the topmost or the root node. So, and then this particular root node will have children nodes. So, and then that children nodes could have also another children. So edge, yun, no, the connection between our nodes is called an edge. So of course, child are the children of the nodes. If that particular node has both connection towards one node, which is the parent. So usually it forms hierarchical structures. Okay, so the same with the parent, and then um, we also have like grandparents or other books called it as ancestors. We also have predecessors, successors rather, and descendants. So, ang descendants can be referred as the children, no? But not all children of that particular node are descendants of that node. So, naapod siya kalahian. Okay, we also have successors, we also have predecessors, and of course, descendants. So, now we have here the leaf. So, any node without its children, so it means it's an empty node. It doesn't have any nodes connecting to it going downward. So that means it's a leaf. So mura siya, it resembles like a tree jud siya, no? So kumbaga ang edge mo na ang branch, And then katong mga nodes na to mao to ang iyahang leaves, no? If katong na leaves na ana po siya branch, then mag-create na po to siya another node. So something in ana iyang idea. Okay. So the height is the length of the longest path to a leaf. Usually tayo uban na books ha kanilang class, there are other books na ang gi-follow nila is array. Okay? So pag array ilang i-follow na data structures, usually they start with 0. Kasi index, ang array jud, programmatically starts always with 0. Okay? And then, naiuban books na ang ilang implementation sa tree is array. Pwede naman po array. Pwede rin dynamic arrays like linked list na implementation. So pag linked list implementation, we have an option to have 0 gihapon, but usually wala na jud siya 0 because it is already dynamic arrays. It's not an index-based data structures. So again, you will understand that if ever wala man, or man yung nasabtan akong giingon, you will understand that when we reach data structures and algorithms. So then the depth is the length of the path to its root. So naatay mga formula in getting the height and the depth. So the only way para makabaluta sa height sa tuang tree is we do traversal. So traversal is visiting each node in a tree. But it's not in a linear manner. It's in a non-linear manner. Okay, so kabalo na taan no mga terminologies. Ayan. So by the way, this one is kaning path is a sequence of nodes such that the next node in the sequence is a child of the previous. So let's say I have here start here from this node, and then I will traverse to this node. So that is the path. So 1, 2, 3. So there is 3 in the path from this node to this node. So in ANA now. So that's how you get the path. So also you can do that by traversing your nodes. Okay, so this is so if na ma-confuse lang mo again sa depth and sa height and even sa level, particularly level, no? So namagutay na tawag na level order traversal. So in the level order traversal, there is this what we called also like level 0, naiuban books level 1 ni siya. So let's say this is level 0. So naiuban books na level 1, dili na siya diretso 0. Kasi again, they don't implement array. Okay? So usually man gud ang uban trees are array based implemented. So basta take note mo na. Okay, so we have, let's say this is we follow the traditional or the itong usual na tree. So this is level 0, level 1, level 2. So the depth of the node is the length of the path from the root. So kung sa to ang imuhang pinaka depth, pinakalalom na node mo to imuhang depth sa imong node. So ang height is if your node, it doesn't mean na ang depth sa imong node is let's say 3. But usually we have formula for that. Pero ang ginabuhat ang sa depth manggod is let's say naatay another node diri. So if you we can say that the depth of the node is up to this one. So let's say this one is 1, 1, 2, 3. So 3 iyang depth. Pero pag maingon ta og iyahang let's say height rather, height of the tree. Pag maingon tag depth of this node, particularly kani siya na nodes from here to here, it's only 1 and 2. Okay, pero let's say na connection dire I have here. This is the depth of this node to this node is 1, 2, 3. Do you follow? Kuha ninyo ang point. I just hope so, no? Okay, thank you. Ayan. So again, don't you worry na siya yung mga formula. So leaf and internal node. So natay ginatawban po na libro class, ginatawag na siya og external node. I mean napo siya ginatawag na external node. So kanang external node nato. So let's start with the leaf, no? Leaf mao ni ato ang mga nodes with no children. So wala na siya edge, connecting towards another node. So basically it's an empty node. It is pointing to null address. So also we have internal node. So it is a node that has that is not it is a node that has either one or two children. So that's internal node. Usually we call it as obviously that's a parent. So we have this also called as like terminal node and external node. So halos parehala na sila ani. Okay, not na term. So leaf is the external node, terminal node or internal node are parent nodes. Okay, so please remember that one. So yan, okay, left sub 3, right sub 3. So of course, left sub 3 are those nodes na ang edge niya going to the left or towards left, towards right. So usually natay ang implementation jud sa ano sa mga searching is implemented using the concept of binary tree. Sa general trees, pwede pero it's a little bit parang complex kasi if it will have multiple nodes, let's say na siya na nodes din ay nodes, so they have 5 children, isa ka parent. So ang searching would be also difficult kasi again daghan kag options. Unlike kung binary tree, you can only go to left and right. Either left and right lang jud imong padulngan. So yan, no? Yan, this is level. So again, ang uban level nag ano with 0. Other books ang ilahang level is nag-start sa 1. Ang atong i-follow is 0. Okay, level 0. So let's follow the idea of array index. By the way, if ever na akong connections to, there's something wrong with sa mo ang internet, naga-loss siya, naga-blink ang pula, loss of signal in case na dili ko like you cannot clearly hear my voice kasi naga data lang ko, so medyo hinay ako ang ano sa connection. Okay, so let's continue. Ayan, so height, then the depth. So ayan, depth 0, 1, 2, 3. Uban, pwede, ang uban is, this is depth 1. But usually, ang ano dyan is depth 0. And then, of course, kalalo, ang iyahang next depth is 1. And depth is 2. So, let's say na siya another node there. So, depth 0, 1, 2, and 3. So, the depth of the node from 7 to this node is 3. Okay, not all. Because this is like a balanced tree. So of course, they all have the same depth. So ayan, further mga definitions and example. Okay, so there are different types of a tree. Actually, there are lots of the parang types or kinds of trees. So natay natawag na general tree. This tree has only one. It's a tree with having multiple childrens. This is usually more than 2, no? So that's a general tree. But if a node or if a tree will have at most 2 children lang, that's the time we call it as a binary tree. So sa binary tree daghan pod og mga types. So natay ginatawag na binary search tree, naatay tawag na balanced tree. We also have this what we call full binary tree, full binary tree or full binary tree or full tree, and we also have complete binary tree or complete tree. And then expression tree, we also have a discussion about this one. So this is usually ang ginagamitan sa expression tree is calculation on complex expressions, no? Usually katong mga postfix and infix notations. And then we have also an AVL tree. This is a self-balancing tree. And kasi ang tree must be, naiuba na idea or concept sa programming na we'll need to make our tree to be balanced. No? So dapat ang ihang ano is na dili more than 1 ang difference sa height ni left sub-tree and the right sub-tree. So that's, we can say na a tree is balanced tree. So we're also going to discuss this further in these data structures and algorithms. Again, daghan kay mga variations sa tree. So let's now focus on the binary tree. So wait, balik ta sa Ayan. So binary tree again, any tree with at most 2 children is binary tree. So pinaka either naay isa ka child or at most 2 children. So that's binary tree. So kaya itawag siya binary. In fact, kanang mga ginaano nila na networking scheme, 'di ba? Usually it follows the idea or the concept of tree or binary tree. Kanang naaga ni say tawag ana sa networking ng mga businesses kanang naay kay say tawag na to ana sila ha kanang si term
Pyramid.
ana pyramiding no naka pyramid like ikaw ni say tawag na term ikaw ni manager na lang so ikaw ni manager and then nakay mga sub.
Upline.
Ayan. Thank you for that no. I'm out of vocabulary. So imuhang sa tawag na to network
Upline.
upline ka tapos ang tawag nato sa baba unsa to siya?
Downline.
Oh my god. So in ato na ka simple networker go rin ni si Kuan Julia. Julia
Akong ano po, akong sister and mother.
Wow, really? Ansa na networking?
Sa akong sister is front row and then sa akong mother kay Royal.
Kaya pala gwapo imong kutis kay naga front
No,
row man no? Naga front
really
row man
sir. Ano sa inborn sa?
ay inborn Kuan wait, kuan born like this.
Oh, walang halong
Oh,
chemical.
wow, okay. Okay naman na no okay naman na as long as you are it will make you parang it will build confidence sa imong self so there's nothing to worry about it but yeah if it's natural then that's good so ayan no kana gi-apply na siya into that one so naalay mga kuan lang jud no like mga networking or pyramiding scheme na ginagamit siya out of this topic niya na ginagamit siya um, for scam no mag-scam mga like particularly mga Ponzi scheme kanang naalan sila yung quota or gina-reach na target and after that they will just perish mawala lang kalit anyway going back to where we left off that's binary tree no so a tree with at most 2 children is called binary tree so there natay 3 dire so um this are all this kuan parang this one this tree is a general tree so this is obviously not a binary tree so and this while this one is obviously a binary tree so say property sa binary tree so the property of a binary tree is number one all the number of total nodes on each level doubles as you move down the tree. So meaning to say if all completely filled no imong binary tree mo double iyahang total or iyang sum. So example na kay level 1 then level 2 completely filled na kay left and right. So that's 1 times 2 na siya. So tulo na no. After which nana po kay each of the node di man gud ko makagamit wait ha try na ko. I'm going to join here in my other PC. Just wait for a while. Add this device. Ayun. So, kasi mahinay akong connection. Just wait for a while ha. Just wait for a while. Let's say, kanis akong is mag-words ako. Can you guys see it? Makita niyo akong screen share?
Wala po.
No, sir.
Oh, wait. Ayan. Kana, nana, wala yapon. Kita wala, murag wa po ko'y nakita sa akong pikas PC. Ay, resume man. Resume man pakita. Wait lang ha, i-close na ako. Ayun. Okay, so let's have the draw. Okay, so example, this is your node, and then you have, so as it move towards the the another node, so na siya next node, if it's completely filled, so from 1, then this becomes times 2 naman, it doubles up. So di na ako makita kay napalong og kalit akong monitor, so diri na lang ko be. So we have yan, and then this becomes now we have, so the from 1 sa level 0 na to is 1, then it doubles up, nahimo na siyang 2, no? So we have here 2 nodes. Kapangit po niya kung agi wait lang class kay I want to be perfect on this. So again, this doubles the number of nodes, and then if this will be completely filled rather, so this nodes, this one doubles again its node. So you have now here another 4 nodes in that particular level. So in level 0, you have only 1 node. In level 1, you have already 2 nodes, and in level 3, you have already 4 nodes. So that's actually the katong ginaingon ni Julia no, about pyramiding scheme. So mag-form siya pyramid. Ayan. So now, balik sa ako sa akong PowerPoint diri sa Picas. Sana to? Yan. So that's the one of the properties of a binary tree. So one of the, no, or one property of a binary tree. Another thing is the number of nodes in the last level is equal to the sum of the number of nodes on all other levels plus 1. So unsa daw pasabot niya? The number of nodes on the last level is equal to the sum of the number of nodes on all other levels plus 1. So unsa yang pasabot sa kana na property sa binary tree?
Sir, nawala ata yung PPT po.
Wala? Oh, wait. Yeah, balik dire. So, again, if wala mo nakita sa PPT, ako na lang balikan akong Word, ha? Wait. Manggod mo gana akong, di na siya mo gana, class o sa, ay wala ko yung camera, ganina pa. Naka-off di akong camera. Sorry guys, peace. Karon na ako napansin. Di siya mugana, I don't know, di siya mugana sa Mac OS. Gana man di dati pag upgrade na ako nawal, di na siya mugana. Pero ayan, balik ko diri sa Windows. So, ayan, ang iyahang ano is again the what they call this one, the number of nodes on the last level is equal now to the sum of the number of nodes on all level plus 1. So example na ako diri kani siya, kani daw na no ang kani daw kung last level na node, it's level 0, 1, 2, no? So I have 4 nodes, and then ang sum daw ani is equal to the sum of the number of nodes on all other levels plus 1. So let's say this is di ba 3 man eh. So 3 plus 1. So is of course both 4. So ang last level o katong nodes pataas is equal to the sum of the last level of the node, because it's because of the property of the tree or binary tree that doubles the nodes as it moves down to the tree, no, to the depth of the tree. Ayan. So mo nang unique property sa isa ka binary tree. Okay? So balik ta. Sorry guys ha, wala na ako na. Anyway, dili man importante akong naong, but at least no makita niyo akong expression para dili pud kayo boring. So ayan, balik ta sa PPT. So di na lang ako ni i-present. Alright. Confirm na ako, makita ba ninyo akong PPT? Makita guys? So,
Yes, sir.
okay. All right. So, another binary tree related definition. So, basta ka, ano na ninyo, no? Gets naman ninyo na mga right child, left child. Ayan. So, let's discuss about full binary tree. So, dili sa ta mag-drawing. So, sa full binary tree, this is any tree where each of the node in that particular tree is either a leaf, no, or either an external node, or it is an internal node with exactly two non-empty children. So, dili siya pwede na isa lang iyang child. Bahalag dili siya balance, as well as ang iyahang nodes, or each of the node in that particular tree would have either two children or no children at all. So, like as you can notice, we can call this as full binary tree. Bahalag dili siya same level, basta all of its nodes are either empty, okay? Or parang wala siya children, or dapat two ang iyahang children. So, we call it as full binary tree. So, paraan eh. So, 1 has two children, so 2 and 3. So, basically, duha yang children. So, 3, it doesn't have any children. So, wala siya left, wala siya right. So, kung nani siya left, therefore, it cannot be called as full binary tree. Kung na siya right, the same. Basta, again, it's either 0 or at most two children. Dili siya pwede isa lang ang child. Okay, that's full binary tree. Now, for complete binary tree naman, all levels of all levels at the height of the node, or the tree node, is, and all levels of that except possibly the this level would be completely filled, or dapat completely full, or filled with the nodes. So pasabot ana in layman's term in ani siya. Dili siya pwede na this node right here kanisa dili siya pwede na ang node that will be inserted after this is, or will be inserted here. So example, mag-insert tag 6 niya na child siya, left child siya of 3. Then dili siya matawag as complete binary tree kasi dili naman siya mahimong complete. So ang complete is about to be filled or completely filled. So meaning that that particular tree is going to be kung completely filled, it will be a balanced tree, or it will be a perfect tree. So another example here. So we have here ang atong last level is kani, no? So this is our last level, and it's completely filled with two nodes. Okay? If it happens na ang iyahang nodes are, or this node is connected to the right child of this level, then therefore it's not a complete binary tree. Why? Kasi na ano na niya ang property na it will be completely filled. So it can be completely filled, or it is a completely filled or complete filled binary tree. Do you follow? Nakihaan niyo ang difference between the two, full binary tree and complete binary tree? Yes na, no? Yes. So example, mag-ano ta? Na makita naman yun sa PowerPoint that I have provided. Pero nalang to yung mali dito isa. So yes, this one. How about this one? Is it a full binary tree or complete binary tree? What is this
Full
tree?
po.
Okay, full binary tree. Why is it full binary tree?
Kasi ano po, may leaf and then merong dalawang anak po, yung 36.
Yes, very good, no? Because the children is at most each of the nodes at most has two children, or tama ba ang grammar, have or has two children, tapos ang all nodes is either has an empty child, or wala siya children, and then none of its node na ay isa ka child. So that's why it's full binary tree. Okay, another, let's check. How about this one? Is this full binary tree or complete binary tree? Sure. Kay full binary tree man to ganina, sir. So complete binary tree na. Ako na lang mo tumag. So this is obviously a complete binary tree. Anong complete binary tree siya? It's because this could be completely filled. Once na maano siya tree dire or node, no, mag-create siya node dire, it will be completely filled. So if it happens na kaning 41 is like a child of 31 or a child of 29, this is not a complete binary tree. So this cannot be also a full binary tree kasi there is one node na isa ka children. So again, ana. So next is, let's check. How about this one? Is this full or complete? Tao po. Sana po sila. Ayun, ni chat. Okay, si Albay. Okay, full binary tree. Very good. So, can this be complete? Dili. Dili siya pwede kay ang iyahang last level sa node, it's not actually wala siya nag-follow sa level order technique, no, or level order insertion, which is ang iyahang nodes kay ang iyahang children nasa 29, supposed to be dapat diri para maging completely filled siya. Okay, so that's the difference between full and complete binary tree. So it's not a complete binary tree. How about this one? Unsa kaya ni? Complete or full? Full. Daw be, check na to inyong answers. Gidaw. Pwede mo sundog, pwede ra po dili. How about this one? Complete or full? Ayo, tao po. Si ano daw, Jomar. Hi, Jomar. My friend. Jomar, my friend.
Complete,
So,
sir.
what about this? Complete ni siya? Okay, complete.
Dili, sir.
Dili dili siya complete. Are you sure? So ngano dili man siya complete?
Ay, kulang. Di bitaw ko sure, sir.
Dili ka. Okay, that's okay. That's okay. Sige, dili ka sure. How about si ikaw, Jules? Complete or full?
Murag, ana iwang PPT sir kay neither. Tanaw na ko. Last
Neither.
time.
Okay, tanaw na tong
Neither.
property sa full. Unsa itong property sa full binary tree?
Dalawang anak, isang leaf po.
Dapat each of the nodes either at most two children or dapat tanan nodes niya walay child. Either walay child or at most two children. Dili siya pwede isa. Now, how about this tree? Nag-violate ba siya sa property sa full binary tree?
Yes.
Yes, tama. Very good. Yes. Actually, nag-violate siya sa property sa full binary tree because there is one node here na isa lang ang child. Dapat duha na siya ang children. So dapat na siya other node diri, let's say 18 or 25 or whatever. Basta na siya node diri. Okay, so dapat na siya node para mahimo siyang full binary tree. So dili po siya ma-complete binary tree kasi dili siya completely filled. Tama? Kay dapat kanina node is didto. Gets ninyo? Ako isula akong dito ko sa word. Ay, di na ako ni word,
Yes,
no?
Yes, sir.
Gets
Yes.
na. Okay, oo. Very good. Thank you. So, dapat mahimo siyang completely filled pag diri siya ang 15. Dili pwede na there's a right niya, dili pwede sa left or sa left or sa right, dili pwede sa right, basta dapat left sa 29 para whenever there is new node being added, it will be completely filled. Okay, so yon ang difference between full binary tree and complete binary tree. So therefore, this is not a complete nor full binary tree na baliktad. Basta dili na siya complete, dili po siya full. Okay, this is just a binary tree. Okay, now, how about this one? Dili siya gihapon full kay dapat na node diri na isang child na left. Tapos dapat kaning 22 is or 22 dapat diri siya para maging completely filled. So again, it's not completely complete binary tree and full binary tree. Now what about perfect binary tree? Okay, ang perfect binary tree is perfect, meaning all nodes are in that particular tree has all parang are all are equal or of na equal or same level. So meaning sa left subtree o sa right subtree nimo same level siya. So like this one, no? Magiging perfect siya. So therefore ang complete binary tree is when it is completely filled, it will becomes perfect binary tree. So meaning to say all perfect binary tree is either all perfect binary tree is a full binary tree and at the same time a complete binary tree, but not all full binary tree and complete binary tree are perfect binary tree. Kasi upon seeing or upon based on the property of our perfect binary tree, it also follows that this is a full binary tree kasi all it's hello guys. Hello, can you still hear me?
Opo, naana ka, sir.
Nawala ko kay nay nagtawag. So pag nay magtawag nawala ang iyahang data. Anyway, balik ta. I don't know if you followed if you are able to follow earlier. So not all perfect binary tree are full binary tree and complete binary tree, but not all complete binary tree and full binary tree are perfect binary tree. So kasi it is valid and true because if we are going to notice this one, this can be full binary tree kasi all of its nodes has at most two children and wala siya isa ka node even na naay left or right. Okay, so kaya full binary tree siya. Tapos complete binary tree gapon siya at the same time because it's all completely filled. So ayan, no? Full binary tree, complete binary tree, and if it is completely filled and it is a full binary tree, it can be either perfect binary tree. So mo ni ang matawag nato siya perfect binary tree if it's completely filled. Alright, so other binary tree types. So daghan siya actually, natay ginatawag na balanced binary tree. Ang balanced binary tree is it's the difference of the height of the left subtree and the right subtree is should not be more than 1. So meaning to say, i-discuss na nato na further but ang idea niya is that kung ang height sa imong left subtree if as you traverse then i-minus nimo siya sa height sa right subtree. If it's more than 2, I know, if it's more than or equal to 2, then that means it's not balanced binary tree. Okay? So, example. Example. Tadri na lang kumusulat diretso. Wait ha, pen. Example, we have, ay, di man ay ko ka-connect. Basta, wait ha. Let's say this one. We have this is ang height ani niya is 1 2. So 2 ang height kani 1. So 2 minus 1, so difference of 2 height of the left subtree minus the height of the right subtree is 2 minus 1 is actually 1. Therefore, kani siya, matawag nato ni siya as balance tree. How about this one? Same gihapon, no? Ay, wait. Yeah, not more than 1. So, 1, 2, 1, 2. So, 2 minus 2 is 0. So, not more than 1. Therefore, this is balance tree. Mangita tag dili balance tree kung naa ba. Let's say kani, okay? 1, 2, 3. This is the height of the left subtree. So 1, 2, 3. The height of the right subtree is 1. So 3 minus 1 is 2. Then therefore, this is not a balanced binary tree. Na-gets, class? Nakuha?
Yes.
Okay, that's good. So kung nakuha ta, let's proceed. O basta this is not balanced tree, basta i-minus lang ninyo kung ano yung difference ni height sa left subtree and height sa right subtree. Pag more than 1 gani na, that means ang result is ang difference niya is 2 pataas. That means it's not balanced tree. Okay? So ayan, mo nang balanced binary tree. So degenerate tree, or also called as pathological binary tree, is all of its nodes has only one child. So we call it as pathological binary tree pag tanan node is isa lang jud ang iyang child. Either ang iyang is going let's say one node, makasulat pa ko pen. So one node, tapos this is another node, and then this is another node, this is another node. So matawag nato ni siya as degenerate node or pathological binary tree. Okay? So tanan internal nodes niya has only one node. So skewed binary tree, either left skewed or right skewed. Ang kanang obviously pag ang imuhang nodes is a degenerate tree or pathological tree, pero moving towards the right. So that's right skewed. Pero pag moving towards the left naman, it's left skewed. So degenerate tree yapon siya or pathological tree. Kaya lang iyang property is dili siya, unlike siya diri na naga-zigzag, no? So left na, then right, left, right. So this is mainly ano lang jud siya, pathological binary tree. It's not left or it's not a skewed binary tree. Naisahay na ang tree. So kani siya, it's a pathological binary tree, both of this, but particularly this is the right skewed and left skewed. Okay, left skewed binary tree. Okay? So ayan, no, this is pathological, this is left skewed and right skewed. So ayan. Then to summarize, we have full, complete, degenerate, perfect, and balance. So kani balance because this is 1, 2, 1, ang height niya 1, 2, 3. Ang height ani 1, 2, so 3 minus 2. Ang result is, or ang difference sa height of the left subtree and difference sa height, ang difference sa height sa left subtree as well as and the right subtree rather is not more than 1. So therefore, it's balanced binary tree. So napo tayo mga trees like AVL trees, spanning trees, and a lot more than kay mga trees. So di lang sa nato to i-discuss, kanilang sang basic, no? I mean kanilang sang mga sa fundamentals of binary tree. So by the way, ang binary tree node consists of three parts. Sa linear discrete structures or linear data structures, ang iyahang node is ano lang, ang composed only of two parts, ang data or the value and the pointer, which is going towards the right lang, no, padulong lang siya, linear manner. Pero ang sa binary tree kay naa siya pointer to the left and pointer to the right. Kaning pointers, if you're familiar with pointer in C++, which happened na wala na sa mga bag-o na mga languages, So this is usually ang ginabuhat ani is so that we are able to store data dynamically. Now we use the address of RAM. Manguha tag address sa RAM, dito na to store ato ang data instead of i-store nato siya sa static na mga variables or fixed na mga variables. So mao na siya, no? That's the idea of though sa Java and sa Python and other programming languages wala na pointers, but they have this what we call reference. So that is why ang other books kay ginatawag ni og reference to the left and reference to the right. Okay, so this is the graphical representation of a tree node. So you have the data or the value, and each node na siya left, which points to the node to the left, which has data again, and left that points to the other node. Pero this time, this is a node which is a leaf kasi wala siya left and right because it points to null. Okay, so the same thing with here. Ayan. So sa binary tree, there are basic three operations: the insertion, the deletion, and the tree traversal, which compose of ang tree traversal either depth first traversal or breadth first traversal. Tama ba? Akong pagka-pronounce, depth first o breadth first traversal. Okay, pero ang sayon lang man tong level order traversal sa tree kaning in order, pre-order, post-order. I don't i-discuss pa nato ni or na-gets na ninyo ni? Mas pasan ako, wala naman ningog. So, basin, I'm already taking much of your time. Anyway, sa insertion sa binary tree is as simple as ano lang, we just follow the level order techniques. Kana. So, meaning to say, kung mag-insert ta og tree, mag-insert tag node to a tree. So, this is your first node or imong root node, and then you have pangita po sa kong basta node na siya. Next is you have the another node, you have here another node. So you just follow the level order technique. So meaning each level dapat completely filled. Okay, so ana no, inana ay ang pag-insert sa binary tree kasi walay it doesn't have any specific rules, no? Unlike other trees na mga special trees kay naay rules in upon insertion. Pero since binary tree ato ang gina-discuss karon, it doesn't follow any rules. Ang iyang ginaano lang is level order techniques. So ana lang, insert root left right, then left subtree left and right, then right subtree left and right, and then left subtree left and right, so on and so forth. So per level jud ka mag-insert, dili pwede na mag-insert ka dili na pod. So like mag-insert ka do. So dili na siya pwede. Dapat when you insert a node, it should be okay, erase na to na siya. Basta it should be something like here. So kani mali na ni siya. Okay, sorry. Basta dili na siya pwede. Dapat diri siya. Okay? Ang deletion, so according sa naay mga techniques or different algorithms sa pag-delete sa binary tree. Pwede man ta mag-delete og specific node, but usually ang ginabuhat for deletion sa binary tree is it follows the level order techniques. Nang iyang i-delete is katong rightmost element. So dili pa sabot na rightmost element na kung I have, let's say, example lang, still, no, this is a wait, binary tree man gihapon pero if we follow the operation or the insertion process, this is not this cannot be, no, pero pwede na tree gihapon na siya, or we can call it as binary tree gihapon. So now if you have, let's say, if you are going to delete a node of this particular na tree, so rightmost dili ni siya ang rightmost. Ang rightmost ani is kani. Kasi mao na siya ang level order techniques, rightmost. So kung mag-delete ka og node sa binary tree, ang ma-delete kani. No usual or kanang basic na deletion sa binary tree. So ma-delete kani ang ma-delete. Now, if mag-delete kag another node, the node that will be deleted will be not ni delete ni siya kay again ha, rightmost element. So kung ingon tag rightmost element, sir, naman sa right subtree ang rightmost element which is this one. No, ang rightmost element is katong recently inserted node. So if you are going to ask yourself which one is the, if we follow the level order techniques insertion, which one is actually the recently inserted node? Obviously this one. So kani dapat ang ma-delete. Gets? Nakuha, class?
Yes, sir.
Okay, very good. So, dili na ta sa level order techniques or traversal. Kailangan pa ni i-review or unsa man? Gets na ninyo ni?
Gets na ata, sir.
Gets na ni? Okay, basta kani is unsa man ni? Left node, right. So, visit the left, then the node, then right. So, kaning pre-order is node, left, right. So, visit the node, print it, then left, then right. Ang post order naman is left, right, node. So, visit the left, then the right, and then node. Sige, mag-sample lang ta, bisan kadiyot or bisan gamay lang. Okay, i-discard na to ni. So, let's go here. Sa pikas na ko na computer. Kaya lang nag-off siya ang iyang screen. Akong GPU siguro niyang error. Nag-ano dyan siya. Wait lang. Can you still give me one pila ka minutes?
Okay lang, sir.
Okay. Sige. Dili na lang ta sa ano. Dili na lang tangita na lang tag node diri. Kanina lang. Si kanisa ta sa pinaka-simple. Okay, kanisa. Okay, si diri sa ta maghimo og or mga so let's start with pre-order, no? So level order. Ang level order, simple ra kayo ang level order. Ang ako isulat dito na lang sa baba. Wait ha, dito na lang. Okay. So level order tayo. Level order. Can you still see it? Level order traversal. Okay, very good. So level order traversal, it is actually easier kasi all you just need to do is visit lang mo left, node, left, right, pero in each level. So, okay. So, if i-traverse nato ni siya in level order, ang value is 24, 22, 36, 35, 38. Yan, inana lang, no? Okay? So, pag in order, so in order traversal, visit the left, node, and then right. Okay? So, therefore, if i-traverse nato ni siya with node, left node and right, or using in order traversal, so left, so this is 22, node, so next is 24, then right. Now, pag visit niya sa right, it's a node and it has a left node. Therefore, you will need to go back to the order of traversal, which is left node, right? So, dili nimo i-print directly ang 36 but rather ang 35. So, here, you will print the 35 instead of 36 because mawala ang order of traversal. So, unahon nimong 35, the next is the 36, which is the node, and then 38 as your as the last or the right node. So actually ma-check ni mo na siya by this one. So mao ni imuhang pinaka left or leftmost, usually ang nasa dire mo po na imong rightmost. So left, which is 22, ang rightmost nimo 38, and then ang imuhang node is in between 22 and 38. So since this is not a perfect binary tree, therefore ang 24 is like dili siya balance. Okay? Dili siya balance na. Kung this is perfect, balance yun na nasa center ang 24. Okay, so that's how to check. Okay, next is pre-order traversal. So pre-order traversal naman is node left right. So visit the node, print it, then visit the left, then print it, and then right. So so let's go and traverse pre-order traversal using this what they call this one tree. So node is 24, then left is 22, and then right in the pag-abot niya sa right, it's a node. So since ang order niya is node left right, therefore print nimo diretso ang 36, which is a node. And then after which left, which is 35, and then you have here right, which is 38. So if you check, ato ang node is 24, so nasa sa pinaka left, and then ang ato ang left na node is the 22, nasa sa center naman, no? And then if again it's this is completely or perfect binary tree, at 22 na siya sa center, and then obviously atong 38 na siya sa right, which is na siya sa, because it is the rightmost node. So in or post order, so post order naman is left node and right. So no left node and right. So basically visit the left, which is 22, then node, which is 24, and then right. So pag visit niya sa right, it's a node that is completely filled with left and right. So kung tanaw nimo ang order sa post order is left node right. So since this is a node but it has a left, so unahon sa nimo ang left. Therefore, go proceed with 35, and then
Sir, wait lang po. Post order po. Nag-the-same na siya sa in order po.
ay mali ang keyboard, dapat left right node ni siya. So mali ang keyboard. Sa man ang keyboard nako palitanan og bag-o. So left right node. So left. So thank you for that, Jules, no. You have a very bright eyes. So left 22. Thank you. So mali ang keyboard ato, dili ako. Left right, so which is 36. Tapos since 36 is a node with completely filled na children both left and right, then therefore mobalik ka sa order of traversal, which is left right node. So left nimo is 35, and then right nimo is 38, and then ang node nimo is 36, and then 24. So ayan, left, tama ba? Left, right, then left, right, node, node. So i-check na to, left most na to is 22, ang right most na to is nasa tunga 38, and then ato ang root node or which is nasa pinaka right most 24. So kung mapansin ninyo class, yeah, mao to ang checking, yeah, and ana. So if you observe, among all the traversal, na ay isa dira na iyahang i-sort pag especially pag binary search tree, pero di pa man naman di ay pag binary search tree ang in order kay iya siyang i-sort. So mahimo na po na siyang sorting algorithm. So ang tree pod pwede pod siya way to sort the data in order. So kaya siya gitawag in order traversal. But if it is binary search tree, sige lang, we will still meet next week. I-meet na gihapon ta mo sa for binary search tree. Although na ako'y video discussion ato, but if you wish to na mag-discuss ta ato like kinani, of course I will welcome that possibility. So do we still have to have more examples or dili na? Do you want more examples?
Okay na ata to, sir.
Okay na to? Okay. Sige. Thank you if that's okay. So if in case lang ha, like especially for those people, no, students na who are not here, then makita nila ng video, if na confuse mo again, pwede ko ninyo i-ano for another session, no? Basta as long as we are both free and we can actually negotiate the date and the time. So thank you for making this possible, Julia, no? So for everybody. So I know nakuha naman dito ninyo, pero naalang siguro mo ginapa-clarify or something na medyo baggy sa concepts of binary tree. So, shall we meet next week for binary search tree or delete na? Okay na ba itong video recording?
Okay na po yun, sir.
Are you sure? Sige ha, pero in case ina lang Jules kung naay magpa special session like ang uban, pwede ipaingon lang sa ba? How do I say this? Iingon lang kanila then inform lang ko. Ikaw ba pwede nga ikaw lang mo inform sa ko but if they don't like that, pwede naman i-direct ko nila og contact.
Sige, sir.
Okay, sige. So, thank you kaayo sa pag-attend for this session, no? It means a lot. And although of course now you have your own pacing already kasi you're already thank you for na okay na mo sa inyo ang video recording nako. So ang inyo na lang is you will like try to search siguro sa other Google or I don't rely on my katong mga resources nako. You can actually be open to look for any other references para at least we can argue if ever na ay mga mali na information that I have given to you. Okay? So again, thank you for coming in. Are we okay, Deuce, William, James, Jomar, and Jan, Sebastian? Are we all good?
Okay, fight, sir, fight. So, yeah, sir.
Yes, sir.
Hope to see you next, no? So next week kay face to face man namo pero wala tay lapot kaya di man ta paired na course. So katong paired course pero makita man gyapon mi last time murag nakita mi ni Estel. And abot kisa pa to kung nakakitaan basta na ako yung mga nakitaan sa inyohang Python man to na subject. Okay? Anyway, so thank you guys and have a great day ahead. Bye-bye.
Good day and thank you, sir.
Sige po. Salamat.
Thank you, sir.
Sige po. Ina lang ninyo ha ang video ma-access nila dire.